All right, so today is day 2 of differentiation rules. So we're just going to use those rules we learned about yesterday to do some different style problems. These are very common type of problems that are asked about on the AP exam a lot. All right, so determine the points at which the given function has a horizontal tangent line. Okay, so what you want to be when you see that horizontal tangent line, that should immediately make you think slope is 0, because horizontal lines have a slope of 0. And then for calculus, what that tells us is the slope is f prime. So this is telling us that f prime has to be equal to 0. All right, so you take your function, you find the derivative, f prime of x is equal to 3x squared minus 12. Then this problem said that f prime had to be equal to 0. So we do 3x squared minus 12 is equal to 0. Work out the algebra. Don't forget your plus or minus. So x equals plus or minus 2. It did say find the points. Remember, points mean you have to have an x and a y. So now that we have our x values, we're going to plug those back in to our function. So we're going to do f of 2. So that's 8 minus 12 times 2 is 24, which is negative 16. And then f of negative 2 would be negative 8. And then negative times a negative is a positive 24. So that would add up to positive 16. All right, so let's write out a sentence for our answer. F has horizontal tangents at 2, negative 16, and negative 2, positive 16 horizontal tangents. If you want to write it because f prime is equal to 0 at those points. All right, so you have a second problem here, same thing. So I would encourage you to try this one on your own. It does have some trig in it, but you should be able to handle that. All right, and unpause the video when you're done and see how you did. Okay, so this one, we do the same thing. So horizontal tangent line means f prime is equal to 0. So we take the derivative. That's 1 plus 2 cosine x. We set our derivative equal to 0. And so that's going to be cosine x is equal to negative 1 over 2. And then we use our unit circle on this one. Cosine is equal to negative half in quadrant 2 and quadrant 3. And that happens at the pi over 3 locations. 2 pi over 3 and 4 pi over 3. All right, we need our y values. So we're going to plug these back into the original function, f of 2 pi over 3. So that would be 2 pi over 3 plus 2 times the square root of 3 over 2. That's sine of 2 pi over 3. 2's cancel, so you get 2 pi over 3 plus square root of 3. Ugly number, but that's what it is. F of 4 pi over 3 would be 4 pi over 3 plus 2 times negative square root of 3 over 2. When we're in quadrant 3, sine is negative, 2's cancel, so you get 4 pi over 3 minus the square root of 3. All right, so F has horizontal tangents at 2 pi over 3, comma, 2 pi over 3 plus the square root of 3, and 4 pi over 3, comma, 4 pi over 3 minus the square root of 3, because f prime is equal to 0 at those points. All right, next one. Find k so that the function f of x equals x squared plus kx will be tangent to the line y equals 2x minus 9. Okay, this one's a little more challenging than it looks, actually. So there are two things that you need to know. A function is tangent to a line at a point. So these two have to be equal to each other. So x squared plus kx has to equal 2x minus 9 at some value of x. We don't know. Okay, we can't really do a whole lot with this right now. Okay, so the other part is that the slope, if it's tangent, the slope has to be equal to the slope of this line. All right, so tangent to this line means f prime has to be equal to 2 because the slope of this line is 2 and the slope of this function is f prime. Okay, so we're going to find the derivative of our function, f prime of x is equal to 2x plus k. And then this equation says 2x plus k has to be equal to 2. So now we have a system of equations. We have one equation with x and k as our variables and a second equation with x and k as our variables. So we need to do some method of solving here. Substitution is going to be the best way to go. So I'm going to subtract the 2x over. That gives me k by itself. And so now I can do a substitution over here. Okay, so I have x squared plus, this is where I'm going to do my substitution, times x equals 2x minus 9. So that substitution I'm making is my 2 minus 2x going in for k. Draw my parentheses a little nicer. All right, so now I can do some algebra with this. It is a quadratic equation, so I'm probably going to have to factor. I definitely need to distribute my x in here, so let's do that first. X squared plus 2x minus 2x squared. And quadratic functions need to be equal to 0. I'll do that later, so we'll just keep this like that. All right, combine like terms. 2x minus x squared is equal to 2x minus 9. All right, so the reason I waited to get it equal to 0 is because I want to move the stuff on the left to the right because I want my x squared to be positive. So I'm going to add x squared, so I get positive x squared. I'm going to subtract 2x, which is actually going to cancel the 2x's out. And I'm left with my minus 9 over there. That's equal to 0. X squared is equal to 9. X is equal to plus or minus 3. All right, we have not done it yet. All right, read your question again. Find k. We haven't found k, we found x, but we can easily find k now because k is equal to this. K of 3 is equal to 2 minus 6, which is negative 4. K of negative 3 is equal to 2 plus 6, which is equal to 8. So k equals negative 4 and k equals 8. All right, just to give you a nice visual of this, let's graph this function in Desmos, and we'll graph our tangent line. I think it's a little confusing, like how did we possibly get two answers here? But it makes sense when you see it visually. So let me get Desmos pulled up here. All right, so we have f of x equals x squared. And then one of our k's was minus 4. So that goes in right here. So minus 4x. So that would be that parabola. And then we have our tangent line, y equals 2x plus 9. It must have been minus 9. Minus 9. All right, so you can see that it is a tangent line, and the point of tangency is right there. There's our x value of positive 3. And if we had plugged it into the original function, we'd have a y value of negative 3. All right, if we change our k value to plus 8, it would be x squared plus 8x. Can't see it right here, but if I zoom out a bit and if I move my graph up, there we go. You can see that it's still tangent. There's our x value of negative 3. Y value would be negative 15. So I think it makes sense visually if you see it that way. Hopefully it does. All right, looks like that was it for day 2. Yeah, certainly is. All right, so you got your homework there at the bottom. Hopefully that went well for you. I'll see you for the next video.